The next part we're going to talk about is mid-latitude weather, where we live. So we're going to go into that a little bit now and see what we can learn about it, shall we say. What types of systems do you think about when you talk about weather in the mid-latitudes? Well, first thing you need to learn, we talked about air masses before. Air masses will form wherever the air kind of stays over one area. It takes on the characteristics of the ground that it's over. Uh, that's generally going to happen with high pressure. Think about it. The winds are light and high pressure. Uh, the air is going to stay over one spot for long periods of time. So if you were to look at the United States, where would our air masses come from? Well, could get one out of the tropical Pacific down in here. Air is warm from the moist and moist. Could get one out of the Gulf or tropical Atlantic. Both are going to be very warm, moist air masses. So they're maritime tropical air masses. Now, in the desert Southwest, especially in the summertime or even in the winter, very dry air, typically very warm, humid, not humid, very warm air though. Can get quite hot. We get some of the extreme temperatures out in places like Arizona, New Mexico in the summertime. So this is a very continental tropical air mass. The tropical just signifies the warmth. The maritime means moisture, continental means dry. Wintertime, we get air masses that form up over central Canada. Uh, when it gets cold, air coming in, they're typically air masses that have formed over that area. We can also get some air masses that form over the northern Atlantic or northern Pacific. When they come in, it's more humid, but it's still cool, not pleasant necessarily. Sometimes they come down along the east coast of the United States. They'll bring in a deck of fog with them, low clouds, lots of temperatures well below normal, maybe, but it just feels miserable. We talked a little bit about Arctic air masses that form up over the Arctic region, over Siberia. When they come in, typical, very cold, very dry air mass. So all of these air masses get their properties from where they form. So when they begin to move away from where they form, properties are going to modify. That's why an Arctic air mass that forms up over northern Canada is not going to be as cold by the time it gets down into the United States. It's not going to be 50, 60 degrees below zero, maybe 40, but it won't be as cold. It'll be gradually moderating as it comes south. Tropical air masses, on the other hand, will come in, they'll moderate as well. They'll begin to get rid of some of the moisture, and they'll get rid of some of the warmth it had with them because it's going to be getting cooler. So let's take a tropical air mass that forms off the Pacific coast. Lots of moisture out there, right? So if I have that air mass moving in from the Pacific Ocean into California, what's it going to do? Well, it's going to rain because the air is going to get lifted up over the mountains in California. It's going to begin losing some moisture. It's going to go down on the other side of the mountains. It's going to warm up and dry out because it's warming makes the temperature, relative humidity go down. Now it's going to hit the next set of mountains, the Rockies. It's going to lose some more moisture so that by the time it gets into the Midwest, it's lost a lot of moisture. It's not anywhere near the same temperature as it was when it came ashore. So it has changed significantly by the time it crosses those mountain ranges. So where these air masses intersect is a front. Fronts that don't move are stationary. And that can happen at times, especially in the winter, especially here in the summer right now. We're having several of those very stationary fronts, lots of precip along them. And remember, cold air is denser. So it's going to cause the warm air to go up and over it. So when the front is stationary, the air is going to be rising up from the warm side and going to pull any moisture that might be there, begin to lift there. And that's where the precipitation will occur. Warm front, Only reason it's called a warm front is warm air is advancing. In other words, the cold air is retreating and warm air is advancing. Cold front, cold air is advancing. And remember, cold air is denser, so it acts more like a snowplow. It really pushes the warm air out of the way, so it causes air to rise very quickly. Fronts typically come out of the northwest. All on the east coast, sometimes we get these backdoor fronts. I was talking about the maritime polar air coming in off the North Atlantic. This is how they get here. You can literally watch the clouds move down across New England, down into Pennsylvania, New Jersey, and they'll stack up right along the Appalachian Mountains where no clouds on the west side, very cloudy, very drizzly on the east. Occluded fronts. All right, let's see if we can get a little picture of that. What happens is you get a very strong cold front that has pushed along, and it's because of the low pressure system, the cyclone, it is overrun that warm air that's been up ahead of it. It literally pushed all that warm air. There was another cold front out ahead of the warm front, so we just pushed that whole warm front up aloft. So all the warm air now is aloft. If the air is colder that's coming in behind the cold type occlusion, that's a cold type. If the air is not as cold coming in from a warm type occlusion, that's called a warm occlusion. Warm occlusions typically occur on the west coast of the United States more frequently. Cold occlusions typically occur on the east coast of the United States. Norwegian cyclone model. This was the original thing. We talk about extratropical cyclones. You get them all the time. Wherever you live in the United States, you're getting a extratropical cyclone. Extratropical means there's a strong temperature contrast right here. And with that, when you start that temperature contrast, well, now aloft, one of those jet streams has come in and created divergence. So what happened is the air started to lift, low pressure developed. This is the initial phase. It has a warm front and a cold front, all because this began. The stronger it gets, cold air gets pushed south from this low, warm air gets pushed north from this low. Remember, warm air is rising up over the cooler air up here. We're getting a bigger and bigger cloud band, more precipitation, continues to intensify, and now we're getting an occluded front. What I tell you, that warm front that was here got overrun by this cold front, you wind up with an occluded front. And the stronger that gets, more occlusion occurs, bigger area. Notice it looks like a comma head. And yes, in the wintertime, many times you can look at a satellite picture and you will see these comma heads around the globe. And you can look at them how they develop from this cloud shape and eventually evolve into looking like this. So you can see this is the strongest low, this is a weaker one, but these are how they progress through the various stages. There's another look at this called the conveyor belt model. It was invented by Dr. Toby Carlson a little while. Uh, Here you're tracking warm air, moist air as a conveyor belt, dry air conveyor, or cold air conveyor. So what happens is the warm, moist air comes up from the south. That's the warm conveyor. You can see it heading up over this warm front now and out to sea. Cold conveyor up to the north. Air is rising up over the low pressure down here, being pulled up, but it's cool air. So it's pulling this cool, moist air back to the west. And eventually it circulates back to the northeast. It's grabbed. Coriolis effect eventually will take a hold of it. But as part of that, that is what creates the comma head. That's why we get a comma shape to that cloud. Now, we need to understand a little bit of the different weather depending on where the low goes. So I got a low that's sitting over Iowa. We could translate that low and put it over Ohio or over West Virginia. Depending on where you are and what sector of that low is what your weather's going to be. Warm sector, nice, warm, moist air coming up. You might get a shower, but probably some sun. May even get a thunderstorm when the cold front passes you. Warm front, to the north of it, you're getting a lot of moisture, some rain, maybe even some snow if you're far enough north into the cold air, but more of the rain closer to the front. And if you're on that side and this low is passing to your west, you're going to be transitioning. You're bringing this warm, moist air in. Now, to the west side and the north, colder air. Remember, counterclockwise flow. If I'm on the East Coast and I'm over New England and I'm bringing this low just off the East Coast, I'm pulling all this warm air up into New England, except it's a loft. It's going to snow very, very hard. Wherever the low is moving, you'll see the falling pressure ahead of it, rising pressure behind it. And lows can form all over the United States. A lot of our low pressure systems in your area in Ohio and stuff come out of the Colorado area or the Panhandle sometimes and move up and across. Along the East Coast, here's your typical nor'easter. And here again, you can see squall lines typically down along the front to the south in the warm sector, snow up to the north. And I want you to look at this. If this low went here, maybe only 50 miles to the west, that person's weather in this area is going to be significantly different than if it had gone 50 miles to the east. So when we're forecasting for your location, where that low is going is extremely important. Now, extratropical means very strong temperature contrast, very, very cold. So there's a very cold side to that low. That means the temperature, because of that, pressure will drop very quickly. You get a much stronger system aloft, actually, than you do at the surface. So that is an extratropical or cold core system. Sometimes we don't get occlusions because it's weaker jet streams. There are also warm core lows. These occur many times in arid areas in the summertime, but they can occur some other times as well. What happens is the heating takes place, pushes the air apart. We know the air becomes less dense, so the pressure drops. Now, aloft, because of that lower pressure, because of that warm air, pressure is not going to drop as fast. You wind up literally with high pressure aloft. So, and the most intense circulation for that low pressure is going to be right at the surface. Exactly the opposite of what we just saw with the extratropical. High pressures are typically associated and come in behind these lows. There's another circulation, sea breeze. If you live along Lake Erie, you felt this. And if you live along the East Coast of the United States or Gulf Coast, even out west, these are breezes that develop because the land heats more than the water during the day. We know that. So that means the air is going to rise over land, lower pressure there. Air's got to come from somewhere to take that place. It comes from the water. So you create a circulation. Mountains, exactly the same type of circulation. Wherever the heating is most, air will begin to rise. Wherever the cooling at night is, we tend to drop down the mountainside. Exactly all caused by temperature contrast. As air moves up and down over mountains, remember it's going to cool, it's going to rain on the top side of the mountain as the air is moving up. As it's coming down, it's lost a lot of moisture, it's going to warm, it's descending. So you wind up with very dry air mass. That's the Santa Ana winds in California that caused all the major damage from the fire weather last year. They form in the mountains to the north. High pressure develops to their north, pushes the air, cold air originally, down those mountains. Fairly dry air already. All the moisture popped out. Gets extremely dry, very strong winds because it's blowing, gravity's pulling it down. The final thing is the hubbub, a dust storm. Think about it. If you had a thunderstorm develop, hits down there and hits a sandy area, blows the sand up or dust up. Well, these can occur in the desert southwestern United States. They occur over the Sahara Desert. All they're doing is literally thunderstorms aloft, except it doesn't, the rain never gets to the ground, but pushes the cold air down, lifts all this dust up, and you wind up with a big dust cloud. So, with that, I just wanted to track the weather here a little bit. We talked about it. Currently, this is the current weather map. We have cold front here. We actually have an area of potential severe weather and flash flooding in this area and along here as well. Notice they're on the warm sector of these fronts. By the day two, fronts have hardly moved. Weak low pressure here and here, but really the front stationary. Again, another threat for some. And again, the front hasn't even moved. If you live in Ohio this week, if you live in the northern part, you're probably not having a bad week. If you live in the southern part, you're not having the greatest week. So, hope you got a little bit out of that. Let me know if you have any questions.